So, James Beamish, the Crop Protection Manager at Salle Farms. It was back in 2010 that we were approached by the UEA if we would like to host this project. The project is called the DTC project and is looking at mitigation measures to keep, in particular, nitrates and phosphates out of watercourses. So, to start with, I'm going to 10 or 12 slides just to give a little bit of brief detail on the host farm. Then I will hand over to Andrew, who will go into a bit more detail about the project. So the reason we were approached is because, first of all, we are within the Wensum catchment, so the catchment area for the River Wensum. For those of you who don't know, the River Wensum starts here to the west of Fakenham. It's a fragile chalk stream that runs through central Norfolk there, runs into the River Yare in Norwich. As I said, we're on the northern edge of the catchment there. We have tributaries to the Wensum that actually start on the estate, so the UEA were then able to monitor right from the source of this tributary what nutrients are going into the water. They have full access to our farm records, as well as, not just ourselves, as well as 7 or 8 farms in the area as well, so they can build up a real picture of what is going on with the watercourses. We're a high input, high output farm, so they wanted a high performing farm to try and see what they could do. So a brief introduction to the farm. We're just over 2,000 hectares, of which 1,700 hectares is cropped. We then have 90 hectares of a Christmas tree operation and amenity woodland. And then there's, as you can see, 237 hectares of both in HLS, ELS, and some permanent pasture. So starting at the top, all spring barley follows sugar beet, 160 hectares all grown for malt, 223 hectares of spring beans. These are all grown for human consumption. We've been growing these now for 15 years plus, put a lot of attention to detail into brookage control so that we're reasonably confident we can make the grade each year and sell them into the human consumption market. 255 hectares of sugar beet. We're responsible for delivering a fraction over 22,000 tonnes to the Cantley factory, so we generally produce this around about 250 hectares of sugar beet. 200 hectares of winter barley. We generally split this. We grow feed barley on the stronger soil types, and then malting barley on the lighter soil types. 582 hectares of winter wheat, all grown for feed, predominantly all first wheats following the 3 break crops. And then, as I said, we've got a small Christmas tree enterprise where we produce around about 15,000 trees a year for local garden centres, and we also have a retail shop on the estate where we sell to the general public. And with the arable operation at Salle, we stick to 2 main principles. And the first principle, and above anything else, is the rotation. Back in the early 2000s, we developed a 7-year rotation, which I'll go into detail in a minute. And we do not deviate off this 7-year rotation with market forces, with any so. We're now, nearly 15 years into the rotation, so we're only now really coming into the 3rd cycle of that rotation, and we do not, I can remember 15 years ago, making the cropping plan used to be quite a sport. We'd be 2 days looking at this, moving fields around, juggling them. Now, with the aid of Gatekeeper, I can tell you what we're going to grow on Salle Farms for the next 5 years in probably an hour with a report. So, the second main principle, which again we adhere to, is the timeliness and the quality of our cultivations. We will not compromise on any front. So if we don't think that we are going to be doing the right job on the right day and we aren't treating that operation to get maximum potential, we will either change what we're doing or we won't do it. Probably one of our biggest tools in our toolbox, if you like, is patience. That if we feel conditions aren't right, we will hang on until they are right. But then on the backside of this, when conditions are right, we have got the armoury in the shed and the tools and the trade that we need to get on the fields, do the job as quickly as possible and get back off the fields. Part of this armoury when we started the rotation back in the early 2000s, we took the decision then to block crop the whole estate. Block crop the rotation. So it took us about 3 or 4 years to get the blocks in place, but you can now see that the fruits of a labour that we are now getting the blocks in place, and it looks right. I'll just mention that the big green area through the middle here, that isn't actually one block, that's just the way the rotation has come this year. We've got just under 500 hectares of wheat there in about 4 different blocks. The block cropping has gave us fantastic capacity with the machinery. We've got quite a young team. I am by far the old man of the team. We keep the team well motivated by keeping them educated. We bring them events like this. We keep them involved in every decision we're making, and we meet at the workshop at 7 o'clock in the morning, and the first 15 minutes of the day is having a general chat amongst the team. What are we doing? Why are we doing it? And that all helps. So that as we go through, when we do get those good weather conditions, that team knows how much pressure there is on to go out there and do that job. So if necessary, we'll double up on machines so that we can run them on shifts, so we can then get out there and do a lot of work in a very short amount of time. We've got 2 agri-environmental schemes running, an ELS and an HLS scheme. The main options on this are all the water courses and virtually all the north-south running hedges have either a 6-metre grass strip or a 6-metre floristically enhanced margin on them. Then we have 23 hectares of pollen and nectar mix, and then we have 37 hectares of enhanced wild bird seed. The pollen and nectar mixes and the enhanced wild bird seed, we have located most of these options in like unproductive corners under 90 degrees. So again, with the farm machinery we've got, wherever possible, we can sweep around the corner, and those machines never hopefully, well, they do have to, but as we reduce the amount of time that they have to back into a corner. If we can stop them backing into a corner and sweep around a corner, it again increases that productivity, again means we can get on those fields as quickly as possible and get off them again. So this is the all-important rotation that we've now been sticking to for, like I say, nearly 15 years plus. I will just go through it from the top. So if we start with the winter wheat and the preparation method there on the left, as I said, virtually all the winter wheat is a first-year wheat following either sugar beet, oilseed rape or spring beans. We don't tend to plough very much of it. Most of it is prepared with a disc or don. The only time we possibly might plough is after sugar beet if it's too wet for the disc or don. Following the first winter wheat there is winter barley, still a very important crop for us. We put winter wheat on in front, or we grow winter wheat in front of winter's oilseed rape. Then means we can have an early harvest of winter barley. That then gives us time to get that land ready for the oilseed rape. Following winter barley, the only crop on the farm where we remove the straw, we then apply 7.5 tonne of poultry manure and 8 tonne of factory lime sludge, 1 pass of the disc or don. We then allows us enough time then to leave that 3 weeks to create a stale seed bed, which we then spray off in front of the oilseed rape. We drill the oilseed rape we've got a Lemkin Karat with a stock seeder on it. So after those 3 weeks, we then spray that, as I said, we spray that seed bed off and then drill it with the Lemkin Karat. Winter wheat back into, oilseed rape back into winter wheat. Actually, my slide has been altered. That should say disc or don in front of the winter wheat. So 1 pass of the disc or don and then into the winter wheat. This winter wheat is then followed by sugar beet, and we actually use these 3 years here to really fine-tune our soil structure and get our soil in as good condition as possible to then go into the sugar beet. So 2 years previously, we're getting that sludge on the turkey muck. We're then having 2 years after that where if we've got any compaction issues, we remove those compaction issues. So we then feel when we come down here into sugar beet that we've got that soil in as good condition as we can possibly have it. Early lifted sugar beet generally goes with the disc or don into winter wheat. And then as the season goes on, we will only drill winter wheat after sugar beet if, again, we are fully confident that we can get a full potential crop of wheat out of that field. So generally, end of October, beginning of November, we draw the line under winter wheat drilling and then switch over, getting land ready for spring barley. And at that time of year, if we have got our sugar beet gang going, part of that sugar beet gang is either a cultivator or a plough, so that we are always weatherproofing our soils after sugar beet. Following that crop again, we go into spring beans. Again, that's generally either plough or discord on, and then back up to the wheat again. We did, on my original slide, which is now, we have two places in there, which is one here and one here, where we have got the potential to put a cover crop in, and we'll come back to that later. So the major machinery we've got in use, predominantly most of the tillage work is done by the two Challengers, two high horsepower machines, and again, got that ability to get on the land there, get a lot of work done in a very short time. As I said earlier, we've got the team who are prepared to double up on shift and get a lot of work done in a very short time. Both quite old, both meticulously maintained, and still very good, cheapish horsepower to pull those big machines. These two are backed up by two John Deere 7280s. One of them's generally dualed up in the autumn doing secondary cultivations, and they both got a 6-furrow plough, and they're both on grain trailers during the harvest period. Then just 3 smaller wheel tractors used for fertiliser spreading and sugar beet drilling and smaller jobs like that. We won one single combine, a Lexan 770. Going back to the rotation, that rotation then gives us a great spread of crops for the harvest period. So we get early combining with the winter barley, followed by the oilseed rape, then the wheat and the spring barley, and then into spring beans. So having that long, broad spectrum of crops mean we can combine just over 1,500 hectares of sort of combinable cereal or combinable crops with one combine. Sugar beet harvester, up until 2 years ago, we ran our own sugar beet harvester off our own back. We are a reasonably heavy soil type for growing sugar beet, so we feel we can't really rely on a contractor because we need the flexibility that on the right, and same as any other field operation, as I mentioned earlier, on the right day we need to get there and be on that field quickly enough. So 2 years ago we decided to upgrade the sugar beet harvester, spread the costs. We went in with Rainham. We were able to then justify having a more sophisticated, higher output sugar beet harvester so we can then, as I said, get on with the job quicker. Cultivation equipment, we're two drills, concentrate all the cereals and all the go through the one Vadestat drill. One 18-row sugar beet drill, bought in 2011 with all the GPS switch off and variable seed rates and everything else it will do. And then just the whole armory of cultivation equipment to follow up. And even though on my rotation slide we had our preferred method of preparing those fields, we're not, if conditions don't allow or we need to change, we've got a wide range of equipment there, and we will always use the correct machine on the correct day for that job. Again, some of it quite old, again, well maintained and generally fairly reliable. So I'll just go through a few yields just to see where we are. Winter wheat compared with the Eastern and national average. As I said, we changed our rotation back in the early 2000s, so you can see, late 90s, early 2000s, we were on a fairly flat curve. It was about here where we changed the rotation, changed the cultivation methods, and then started to see that the yield started to increase. By 2008, we thought we had definitely made it, but then the weather came along in the subsequent years like that, and commodity prices were never quite been back to where we were in 2008. Similar to oilseed rape, we didn't change our establishment methods from oilseed rape until later on, so we were a sort of flat curve a little bit later, and then the last 5 years we've started to increase yields there as well. Spring barley, as I said, all spring barley follows sugar beet, so we do get a lot more volatility in spring barley. So if we get wet years, dry years, there is that little bit more risk with spring barley following sugar beet on heavy land as to what you are going to get. But trying to safeguard that by, as I say, keeping up behind the sugar beet harvester with the cultivations. So like that, we find that we can safeguard that land ready for the spring barley. Sugar beet, as I said, we are what you would probably class as some of the heavier soil types for sugar beet. Back in the early 2000s, we were poor sugar beet growers in our minds at the moment. When we look back, we were below national and Cantley average. But again, as the soil started to improve with that longer rotation, there's more attention to detail on the cultivations. As we built up the nutrition, we can see that our curve is then starting to go. And this year, the last few tonnes are being delivered at the moment, that we should be back up somewhere at this level for the crop this year. So last slide from me before I just hand over from Andrew is gross margin performance across the farm. And what I'd like that just to illustrate is really to have the broad spectrum of crops is just that reduces the risk. So you get a year like 2011 with different commodity prices, different yields. You can see where a broad spectrum of crops then reduces your risk. And I normally put another slide in here, but we haven't got it in today. But normally we almost disregard this slide here and have one single farm gross margin slide, which has generally got a nice trend line going through here. Unfortunately, commodity prices, we all know what they've done over the last 4 years. So apart from this top one here, we are slightly on the decline, but down to commodity prices rather than yield. So with that, I will hand over to Andrew.
Thank you, James. Good afternoon, everyone. So at the University of East Anglia in Norwich, we are part of this National Demonstration Test Catchment Project, and there are 3 national catchment consortia focused on the River Eden in Cumbria, the Hampshire Avon, and the Wensum in Norfolk. And these were selected to focus on different types of farming system. And as James mentioned in his introduction, we're looking at some of the ways in which on-farm mitigation measures can reduce diffuse pollution, but we're also very firmly focused on looking at how we can maintain and improve food production capacity. We're very focused on how you can balance both the environmental and the economic objectives. So within the Wensum catchment, we were tasked with setting up a monitoring infrastructure that would allow us to assess variations in stream water quality and chemistry and ecology, and then evaluate the effect of different sorts of on-farm mitigation measures and practices. And we focused on this headwater area in the Blackwater catchment, and you can see an enlargement of it here. The map of Salle Farms that James showed previously basically runs up in this area here. So all this area in the upper part of the catchment is Salle Farms, and then there are another 8 farms in this area here. Within this catchment, we've installed a number of different monitoring kiosk sites. You can see them labelled with the letters on the map there. They are basically automated monitoring facilities that allow us to assess what is coming down the streams at different points in time. So we have 5 of these little mini kiosks that you can see here. They're solar powered. They will measure different sorts of water quality parameters on a half-hour basis. And then they will send those results back wirelessly to a website. So we have real-time monitoring of what's going on in the catchment system. And we can trigger the samplers that you can see on the right-hand side of the slide to take more detailed water samples during, say, for instance, heavy rainfall events. We also have 2 of these rather larger kiosks that basically look a bit like Doctor Who's TARDIS, but they have the kind of equipment in that you can see there. They will draw a water sample from the stream and they will automatically analyze it for a range of nutrients, and then they will forward the results onwards. We set up that infrastructure starting in 2011. We've been using it to monitor the stream conditions. What it's highlighted for us is just how important the heavy rainfall events are in terms of mobilizing nutrients like nitrate and phosphate and sediment down the catchment. So I have one example slide to show that. This is from May last year, where in Norfolk we had a lot of rain in towards the end of May, having previously had quite a dry April and early May when quite a lot of fertilizer was applied. You can see what the effect of that rain was in terms of, firstly, the change in the stream level on certain days, the peaks we were getting here, and then what that did in terms of levels of nitrate and phosphate coming down the stream system. These chemicals, nutrients, respond in very different ways. Phosphate tends to bind more to soil particles, so you get a quite quick, spiky response, the kind of thing that you can see here. Nitrate dissolves in water. You get more nitrate passing through, say, field drains in the catchment system. You get a more gradual response and a smoother response, these curves that you can see here. But we can take this data and we can calculate the sort of nitrate fluxes, the nutrient losses that a rainfall event like this represents. So in that particular period, the losses were equivalent to about 9 kilograms of nitrogen per hectare and a rather smaller amount of phosphate per hectare, but in a period of few weeks. So it's a heavy rainfall systems that really move nutrients through the system. What we're trying to do is reduce the effect of these sorts of events. So from 2013 onwards, we've been working with one of the particular blocks that James mentioned, and we've been looking at how we could introduce different sorts of changes in farm practices that we could assess the effects of. So this is one particular block here. This is on the eastern end of Salle Farm. It's quite close to the home farm, Manor Farm here. There's 9 fields in that area, and we've then split that down to 3 smaller blocks. The control block here, what we've labelled block J on the map, the intervenient block here, these fields here, the 3 here, that's block P, and then these 4 here, block L. What we've tried to do on these fields, we haven't changed the rotation of the estate at all, we've worked with it, but within those 3 blocks, we've basically tried to vary the amount of soil inversion that's taking place in the cultivation system. So that these fields are essentially the normal farm practice. These fields are direct drilling of the crops, and these fields are a sort of intermediate solution. And then added to that, the estate decided to set up their own experiment. So we have these 2 fields on the left here, which are like the sort of the no-frills solution. So in summer 2013, all of those fields were in wheat and barley. So then, before the spring beans, we had the opportunity to put a cover crop in. So what we've done, we've put cover crops on these 7 fields here. So the results I'm going to briefly present to you now are basically what we've got from that sort of period of monitoring through from summer of 2013 through to spring 2014. And the information here just gives you an idea of the variations between the different blocks in terms of the equipment used, the number of passes from the different machinery, and the overall costs involved in doing this. So what we've done is, when the crops are harvested in the summer, in late August we were able to put an oilseed radish cover crop on 7 of the fields. We realised that there was some debate about whether you should have a starter fertiliser with the cover crop. So we actually put starter fertiliser on 5 of the fields with the cover crop and left it off the other 2. We used an oilseed radish because we were interested in having a crop that would have good nutrient retention. We wanted something with a deep tap root, and we wanted something that would be good for the beet nematode control. And oilseed radish on this occasion met those bills. The radish gets established really quickly, So you can see what it was starting to do in some of these fields by 6th of October. It grew very vigorously. We actually had to spray it off in January, and then in March time, into the trash left over from the cover crop, the spring beans were drilled. So this gives you an idea of what the fields looked like when the beans were being drilled and the different methods. We've undertaken a whole series of different methods of assessing the variations in changes in conditions over this time. The map here gives you an idea of the variation in soil conditions across the fields. Basically, the purpler colours are heavier soils, the greener colours are lighter soils. We've measured a whole range of different soil parameters in terms of texture, soil biology, nutrient levels in the crop cover, soil water in the porous pots, and we've actually monitored the field drains. So just very quickly, some results for these. When we dug up some of the cover crop in January, one of the things that we were interested in is, would there be a difference between the crops in the field with the starter fertiliser or not? Actually, in this case, there isn't. But you need to recognise that we got the cover crop established quite early in the season, and possibly if we'd established it a little bit of later, there might be more difference. So in that particular case, there doesn't seem to be an especially strong case for a starter fertiliser. We did see a very strong effect on the soil biology in terms of the difference between the cover crop fields and those where it was absent. There was a much higher diversity of certain types of soil invertebrates like spiders and beetles in the cover crop fields, and that's controlling for the differences in soil texture. So that's encouraging in terms of pest control and so forth. We've particularly put a lot of emphasis on monitoring the implications of the cover crop for the soil water. We've done that in two different ways. We've done it by monitoring a series of the field drains that run along the stream here, these ones that you can see highlighted with the arrows. So they run down, some of them drain the cover fields, the intermediate fields here, the direct drills fields and so forth. And then at a series of sites within those fields, we've also done porous pot samples, which allow us to assess what's in the soil water 90 centimetres down. So what's leached down from the surface and might ultimately go down into the chalk aquifer. So very quickly, a few results. I think this is one of the most striking results from the findings. This is a period of time going from late October, when the field drains started running, through to the end of March. So this is a nitrate concentration, and each line here represents the concentrations in different field drains. The field drain lines that are coloured red, green and orange and yellow are all the ones on the cover crop fields. All the ones from the fields that were either control or had other crops like wheat or oilseed rape going in them, those are the blue shades. The contrast is really, really obvious. And you can see that also if you start to look at differences in fluxes, amount lost. The amount being lost from the cover crop fields is somewhere between sort of 5 and 13 kilograms per hectare of N, and in some of these fields here it's between 7 and actually up to 40. There are some quite interesting changes over time. You can see that there's two fields, these are actually wheat fields, where the leaching loss is really high in the autumn and drops down quite appreciably in the spring. And there's one blue line that runs through there all the time, and that's actually an oilseed rape field. So that's almost like acting like a kind of proto-cover crop. But the impact of the cover crop there in terms of retaining nutrients is really striking. You can see the same thing in the porous pots results. This is telling you what's in the soil's water 90 centimetres down. These are from cover crop fields. You can see what the kinds of values here. The fields with no cover crops, they're almost an order of magnitude higher. There's a lot more leaching down into the soil water. You're losing nutrients downstream because of that. So that gives you an idea of some of the sort of environmental effects. There's clearly a lot of environmental benefit from having those cover crops present. The other important thing is what does it mean for the farm economics? So we're now going to pass back to James. He's going to tell you the financial details.
Good. Thank you, Andrew. We've got to be quite quick, so we're running over time as normal. First of all, I'll rule these two fields out because they are both quite a heavy soil type, and going back to Andrew's slide where we had that 86 millimetres of rain in 8 days, those two fields in patches never quite recovered from that. So the 3 fields that interest me are this one, Far Hemsky, which is one of the control fields, this one, First Hemsky, which is one of the direct drilled fields, and then Moor Hall. They're all very similar soil types, drilled within 2 days of each other, all soil in similar conditions. And as you can see from the top of here, Far Hemsky 5.89 down to Moor Hall at 7.05. So over a ton of hectare difference between where we had the cover crop and where we didn't there. Take that through to some numbers. When we attribute all the cover crops to those fields in 1 year, appreciably that doesn't come to a lot of difference. So 745, 735, 758. What I appreciate here is that you can't attribute all the cost of that cover crop into 1 year. From my point of view, what's going to be interesting now, because they're still being monitored, is what's going to happen in the next 2-3 years. What legacy are those cover crops going to hold? And the no-frills block, which Andrew mentioned earlier, just to put that in perspective, that was overwintered stubble. It had one pass of the discord on 2 days before we drilled it, drilled with a rapide, yielded the same, and in this particular year, then gross margined £100 a hectare more. Just through practical observations we made through the course of doing this, we did struggle to kill the oil radish. It was, I think it was the 18th of January last year, we sprayed it with 4 litres of glyphosate. Where we then went and did, on the hybrid block, we did some quite intensive cultivations, we sort of finished it off. Where we went in with the direct drilling, that looked completely dead when we drilled it, but as soon as soil temperature started to warm up, those oil radish bulbs under the soil all started to shoot again, and we did have quite a bit of oil radish come back. The pre-emergence held it. Actually, for once, flea beetle helped us, and they kept it back as well. But we then had to die-cut all that off in front of the combine. Where we had to top the oil radish in the autumn, again, we didn't have such a good uptake of glyphosate. Andrew spoke about the flora and fauna, the increased flora and fauna behind a cover crop. Unfortunately, this wasn't all beneficial, and we did get some more pea and bean weevil damage after the cover crop than we did where we didn't have a cover crop. Probably the biggest thing that we noticed as every few weeks during the winter we were out in those cover crops and digging holes with spades, and we thought we had this soil structure to die for that was going to crumble to bits in the spring. But unfortunately, when it came to moving the soil in this last spring, where the cover crop had been, where it was destroyed, that soil was noticeably wetter than where we'd left stubble over the winter. So not quite got to the conclusion. My only conclusion could be that the mat of trash that was laying over there just stopped some of the moisture being released. So just one of the UEA's sort of conclusions there, that where the seed hawk drill was and where the cover crop was, that at harvest time it probably looked more even than where we'd done the intensive cultivations. And down the bottom here, that where we were using cover crops and where we weren't using cover crops, you know, there was no deficit on margins or yield. If anything, there was an improvement. So, final slide, the project is due to run now until 2017. It's going to continue monitoring the fields right the way through. Last autumn, the 9 fields were established into winter wheat. So the control block and the hybrid block were more or less the same, with one pass of either a top-down, which Vadastat sponsored, or discord on, where the other direct drill fields, again, courtesy of Vadastat, were drilled direct with a Vadastat seed hawk. Not on these fields, but another part of the catchment, we have got sugar beet coming next year, so there is plans to put a cover crop in these fields, monitor that, possibly a different cover crop, but we haven't yet had that meeting to decide which way we're going with that one. So, thank you very much.